Today we shall discuss some of the optical phenomena which are occurring in the nature. Now first is mirage formation that you must have studied in your 10th standard also. And in hot summer days, the air near the ground becomes hotter than the air at higher level. Okay, so air which is in contact with the surface of the earth becomes hotter than the air which is at the higher level, and the refractive index of air increases with its density. So, as you go above the surface of the earth, the refractive index increases. Hotter air is less dense and has small refractive index than the cooler air. If the air currents are small, that is, the air is still, the optical density at different layers of air increases with height. Means as you go above the surface of the earth, the refractive index increases. As a result, light from tall objects such as tree passes through the medium whose refractive index decreases towards the ground. So light rays which are coming from higher object or a tall object, they are all traveling from the denser medium to the rarer medium. Thus the ray of light from such an object successively bend away from the normal and undergoes total internal reflection. You can see in this figure that the rays which are coming from the tall object, continuously the rays are going away from the normal, as you consider this as a angle of incidence. Here the angle of incidence is less in comparison to this angle of incidence, and the refracted ray is always going away from the normal, and at a particular point where the angle is more than critical angle, then it performs the internal reflection, and the image of this object is formed here, and this image is found to be virtual and inverted image. Okay. To a distant observer, the light appears to be coming from somewhere below the ground. The observer naturally assumes that light is being reflected from the ground, say by a pool of water near the tall object. Such inverted images of distant tall objects cause an optical illusion to the observer, and this is called the mirage. Okay. This type of mirage is especially common in the desert area. While moving in a bus or a car during the hot summer days, a distant patch of road, especially on the highways, appears to be wet, but you do not find any evidence of wetness when you reach at that particular spot, and this is also because of mirage. Okay. Now we talk about the phenomena of total internal reflection in right angle prism. See, this is the right angle prism. Okay, one angle is 90 degree, the other two are 45 degree. Okay, now what happens when the ray of light is incident here? Then this is your incident ray, and this dotted line is the perpendicular drawn at a point of incidence. Now this ray is, say, reflected. This way it is reflected. So here this angle becomes 90 degree. So this angle where the normal is drawn, try to understand this angle. Okay, that is about 45 degree. Try to understand. This is 90 degree. This you can see. Let me make it more clear. Okay, this angle you can see it is 90 degree. So the perpendicular drawn at a point of incidence will bisect this angle, so this angle will be about 45 degree. And if the critical angle is less than 45 degree, try to understand, if critical angle is less than 45 degree, then what will happen? The angle of incidence is about 45, so it will experience the total internal reflection and the light is reflected back in the medium. See, this way it will be reflected. Okay, so this surface of the prism will behave as a mirror, or it is a perfect reflector, we can say. Okay, so this is the way in the right angle prism, okay, the total internal reflection occurs. So prism is designed to bend the light by 90 degree or by 180 degree, making the use of total internal reflection. In this figure we can say, figure A and B you can see. Okay, these light rays are bent at an angle of 90 degree, while these light rays are this way. They are, as such, they were moving in this particular direction, but then they are returning from the prism means there is a bending of 180 degree. Okay, you can easily see. Again, this is your incident ray. Again, normal drawn at a point of incidence will make it reflected again. And again here there will be a reflection and the light ray will come out. So from original path it is deviated, or it is diverted in the opposite direction. So we can say it is having a 180 degree shift, we can say. Okay, here this another prism is also seen in this figure C. In the first two cases, the critical angle IC for the material of the prism must be less than 45 degree, that I have explained. Okay, such a prism is also used to invert the image without changing their size. Okay, that is shown here. Okay, here the image is inverted. See, this is your incident ray. Okay, this is the incident ray which is going in this particular direction. Then it is reflected and it is going in this direction. Now this is the another ray. So it is falling here and it is giving you the image here, which is here A prime B prime. Okay, here it is BA. So the image is inverted. It was like this earlier. The image object is like this. The image is in this particular direction, means it is inverted image. Okay, so this TIR is used to invert the image also. Okay, now we talk about the optical fiber, its construction, working. Okay, optical fibers are also using the phenomena of TIR. Okay, total internal reflection. Optical fibers are made by a high quality composite glass or quartz. Okay, so they are made by the high quality of glass quartz fibers. Okay, each fiber consists of a core and cladding. Try to understand, this internal part is known as core and outer layer is known as cladding. Okay, the refractive index of material of the core is higher than that of the cladding. So this refractive index of core is more than that of cladding. Okay, now function. Try to understand. Okay, what happens here? This is the beam of light which is incident on the core at a suitable angle. Okay, and the signal in the form of light is directed at one end of the fiber at a suitable angle. Suitable angle means the angle must be more than critical angle. It undergoes repeated total internal reflection along the length of the fiber and finally comes out at the other end. Try to understand here. This is the incident ray. Okay, here if you say perpendicular is drawn at a point of incidence, then this angle of incidence must be more than the critical angle. So what will happen? It will experience the TIR many a times within the fiber, and then finally the ray will come out of the other end. Okay. Since the light undergoes TIR at each stage, there is no appreciable loss in the intensity of light. Intensity of light is not changed in a tremendous amount. Optical fibers are fabricated such that light reflected at one side of the inner surface strikes the other at an angle larger than the critical angle. So here the preparation of this core, or rather the refractive index of core and cladding, they are so adjusted that light experiences multiple total internal reflection. Even if the fiber is bent, light can easily travel along its length. Okay. Thus, an optical fiber can be used to act as an optical pipe. So, light ray are always going to experience the total internal reflection irrespective of bending of fiber or any other way you keep the fiber. Okay. So it behaves like optical pipe. Light enters and it comes out from the other end. Okay. Thus an optical fiber can be used to act as an optical pipe. The bundle of optical fiber can be put to several uses. The device which converts one form of energy in another form is called transducer. Okay, what is transducer? It converts one form of energy to the other. Optical fibers are extensively used for transmitting and receiving electrical signals which are converted to light by suitable transducer. Okay. These signals which are converted into light, they are again transmitted to fiber. Okay, this process goes on. Obviously, optical fiber can also be used to transmission or for the transmission of optical signal. For example, these are used as light pipe to facilitate visual examination of internal organs like esophagus, stomach and intestine. Okay. Decorative lamps are also made by these optical fibers. Okay. When the lamp is switched on, light travels from the bottom of the decorative lamp and it reaches to the tip of the fiber. Okay. Some of the decorative lamp like this, okay, are available in the market. If you put the lamp here, okay, lamp here, then what will happen? When you switch the lamp on, the light will travel in this direction and at the tip you will have a bright spot here. Okay, so it is a very beautiful as such the decorative item. Okay, the main requirement in fabricating optical fiber is that there should be very little absorption of light as it travels for long distance. This has been achieved by purification and special preparation of material such as quartz in silica glass fiber. Try to understand this silica glass fiber. Okay, it is possible to transmit more than 95% of light over a fiber of the length of 1 kilometer. So it is very efficient in transmitting light. Okay.